Hi, today we're going to have a quick lesson on how to calculate the percentage composition for a compound. In previous lessons, we learned to calculate the molar mass of a compound. And so we're going to practice that and apply it today when we are calculating the percentage composition for a compound. One thing I wanted to point out here, and I just want to get a good color to do so, is when we look at the formula for a compound, the subscripts in the compound give us the particle ratio. For example, in water, there's 2 particles of hydrogen for every 1 particle of oxygen. So if we're talking about particles, hydrogen makes up a larger amount of a water molecule than oxygen does. But oxygen weighs so much more than hydrogen, so that if you talk about the mass, for example, hydrogen is only 2 out of the 18 grams, whereas oxygen is 16 out of the 18 grams. So if you talk about mass, now the oxygen makes up the larger portion of the compound. So the formula gives us a particle ratio, but the percentage composition is going to give us a mass ratio of the elements that compose a compound. So this is the definition. It is the percent by mass of each element in a compound. And it's going to give us that mass ratio. We start, remember, by finding the molar mass of a compound. So let's review this one, okay? For this particular compound, we have 3 elements. We have carbon, we have hydrogen, and we have oxygen. You look at the formula and figure out how many of each element are in the compound. Now notice there's 7 hydrogens here and another one over there. So there is a total of 8 hydrogens and 1 oxygen. We have, for our purposes, been rounding the molar masses off to the whole number. So we will multiply each of those by the molar mass. We can see that the carbon contributes 36, hydrogen 8, and oxygen 16 to the overall mass of the compound. And what we do then is we just get a grand total, and we can see that it is 60 grams in 1 mole of the rubbing alcohol, okay? Now, you can see that even though there's many less atoms of carbon in the compound, it contributes a lot more to the overall mass than the hydrogen does. 36 out of the 60 grams is carbon. 8 of the 60 grams is hydrogen, and 16 of the 60 grams is the oxygen. These numbers right here are the numbers that we are going to use to determine the percentage composition for this compound. So we're going to use the molar mass. We're going to use the mass of each element that's within the compound, okay? How much of that element is in the compound? We're going to divide by the molar mass of the compound and then multiply by 100. We're going to do that for each element. So for the carbon, for example, there was 36 grams of carbon in 60 grams total. You take that, you divide, then you multiply by 100, okay? And we're going to round off our answers to the 10th. This compound is 60% carbon. You do each element individually the same way. For the hydrogen, it's crazy there. For the hydrogen, it's 8 grams of hydrogen out of the 60 grams total. And then times 100. When you divide that, that comes out to be 13.333. We're going to just round that to 13.3. And then to do the percentage of oxygen, we need the 16 grams of oxygen over the 60 grams total. times 100. Excuse my random line there. And that one comes out 26.6 repeating, which we'll round up to 26.7% oxygen. Now you're going to notice that your three answers right here total 100%. And generally, anytime you do these, if you're rounding off to the 10th, your answers should total to give you 100% plus or minus a tenth. Sometimes all three of the numbers get rounded down and you end up with 99.9. Other times, maybe two of them get rounded up, one of them gets rounded down, something, and you end up with 100.1%. This one came out exact because this was an exact. This one was rounded down and this one was rounded up. So the round down and the round up kind of canceled each other. But if you do one of these problems and your result down here, when you add the percentages, is like 85%, then you know that somewhere along the line, you made a mistake. Either you miscopied a number, you punched a number into the calculator wrong. Every once in a while, I will get people who will accidentally use this mass instead of the total mass of that element that is within the compound. And likewise, if you get something that is larger than 100%, maybe you added the total mass of the compound incorrectly when doing the molar mass. So if you get something other than 100%, give or take a tenth, you need to go back and check your math. And so I think this is great. It's a great way to self-check a problem and see if you most likely did it correctly. So I have these two. Okay. What we did in class was everyone did these and then showed them to me. Okay. And so you can practice these, okay, on your own. And I'm going to pause, or you should pause and practice them, and then restart so you can see the results. Okay, welcome back. There's 3 calciums and it's 40, so that's 120. There's 2 phosphorus and it's 31, so that's 62. And for the oxygen, there's 8 of them. There's 16 each, so that is 128 for a grand total of 310. For each element, you need to take the individual mass divided by the total mass times 100. So for the calcium, I got 38.7%. For the phosphorus, it's going to be 62 over 310 on there, times 100, and I got an even 20%. And for the oxygen, it is the 128 over the 310 times 100, and I got 41.3%. Now, if you did not get one of those, you can go back and check the periodic table or check your math, okay? And you're certainly welcome to ask. For the dinitrogen pentoxide, okay, we only have nitrogen and oxygen. There's 2 nitrogen for every 5 oxygen. That's the particle ratio. But to get the percent composition, we need masses to get the mass ratio. And the percentage of nitrogen is going to be 28 grams out of the 108 total. And the nitrogen is going to be 25.9%. And the percentage of oxygen is going to be 80 out of the 108. And that is going to be 74.1%. So you can see that in both cases, they do add to 100%. Again, though, occasionally you might get a situation where, 99.9% or 100.0. Now, once you're done with these and you, feel confident, you can move on and do the book homework. Remember that the percentage composition of a compound is not going to vary. Compounds have a set particle ratio, which means that they also have a set percentage ratio. Okay? Good luck and see me if you have any questions.